Hello, Leiden geometry students. In this assignment, we are going to talk about ASA and AAS triangle congruence. All right, so what we've been doing in class is talking about ways to prove triangles are congruent. We've already talked about a couple of them. For example, SSS and SAS, that's side, 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 and side, angle, side. We've already spent a few days talking about these. This is two ways we can tell if triangles are congruent, but there are other ways as well. Today, we're going to talk about this. ASA stands for angle, side, angle, and AAS standing for angle, angle, side. And eventually, we'll get to this one called HL. Now, before we do that, something that people start talking about is we have these 5 ways to prove triangles are congruent. And immediately, some people start giggling. What about angle, side, side? Right. Some people start thinking of that immediately. There is no ass in geometry. If you spell ASS, it is incorrect. It is not a rule in geometry. And the same thing, there's no such thing as ass backwards. If you spell ASS or SSA, it's wrong. Not because some people would tell you it's a bad word. I'm just talking about donkeys here, but not because of that, but instead because mathematically it does not work. So instead, we're looking at these 5 ways to prove triangles are congruent. So first, 30-second recap of the 2 that we know. The first one was SSS. SSS stood for side, side, side. That rule said if the 3 sides in one triangle are the same as the 3 sides in another triangle, then the triangles are congruent. Here's an example of SSS where the 3 sides are marked congruent with tick marks. Same here. Again, the triangles can be flipped around and rotated, but we're just looking to see if the sides are the same. If all 3 sides are the same, the triangles are congruent by SSS. Here, again, we have all 3 sides the same. The middle segment's not marked, but we know that that is congruent to itself, and it counts as a segment in both sides. So this is still SSS. Or here we can do it with measurements. If we know the lengths of the 3 sides of a triangle in both triangles and the lengths are the same, then the triangles are congruent by SSS. SAS is basically the same thing, except it's got to be an angle. Now, the angle has to be that included angle. That means it's got to be the angle that connects the congruent sides. If it's some other angle, it's not going to be an example of SAS. But SAS is 2 sides and the angle that connects them, or included angle, makes triangles congruent to each other. Here's an example of side, angle, side, where we'd have to include the vertical angles in the middle. Now we have 2 sides and the connecting or included angle. Here's another example of a side, angle, side, where we'd have to include the reflexive property that the center segment's congruent to itself. Those are the 2 that we've done so far. So next, our 2 new ones, which are angle, side, angle, and angle, angle, side. And they are easy to mix up the letterings here. It's just moving whether the S is in between the A's or not. And it's easy to mix up the pictures as well. The pictures are very similar. Both of them have 2 angles and a side marked congruent to each other. The picture over on the left is what angle, side, angle is supposed to look like. Now you'll notice in the naming, it's A, then S, then A. The S is between the A's, and that's what we need to find in the picture as well. For something to be angle, side, angle, it's about where the side is. If, for angle, side, angle, it's the included side. In other words, it's the side that connects the congruent angles. Here we have these 2 angles congruent and the side that connects them. That's angle, side, angle. Versus the other one, when we have angle, angle, side, it's the non-included side. In this case, we have 2 congruent angles and another side, not the one that's between them. That's the difference. That is the only difference between these 2, is whether the side is between the angles or it's not. It's the included side or the non-included side. So, angle, side, angle. We have 2 angles and the included side congruent. This is angle, side, angle. And we have lots of examples of what it could look like. Here we have, in these 2 pictures, we have 2 angles congruent and a side, 2 angles and a side. You have to check to make sure the side is in the appropriate place. And here, these 2 angles and the side that connects them. In the other triangle, these 2 angles and the side that connects them. That's angle, side, angle. Here in this example, we'd have to include the vertical angles first, but then we have to check. We have 2 angles and a side. Is it the connecting side, the included side? And in both cases, yes, it is. So this would be an example of angle, side, angle. The side is between those angles. In this case, we'd have to add the center segments congruent to itself. We have 2 angles and a side. We want to check to make sure to see if the angle's in the right spot. Here we have 2 angles and the side that connects them, congruent to 2 angles and the side that connects them. This is angle, side, angle. All right, the other one, angle, angle, side, it's two angles and one of the sides that's not in between them, a non-included side. So here in these two triangles, we have this side, but it's not the side that connects the congruent angles. This is angle, angle, side. So we can see several examples might look like this. Here we have two angles and then a side that's not connecting them, congruent to two angles, and a side that's not connecting them. It's the location of that side that makes it angle, angle, side. And again, in this case, if we added in the vertical angles, we have two angles and a side. The side is not the connecting side, so this is going to also be an example of angle, angle, side. It's not the included side. All right, you have to remember there's no such thing as angle, side, side, or side, side, angle. So here we'd have two sides and the angle that's not between them. The other problems are two angles and a side, but here two sides and the angle not between them. These are not congruent. This would write out angle, side, side, which is not an example of congruent triangles. So here's an example where we might use this in a proof. Here we have this picture, two triangles are connected to each other. We know we're going to use vertical angles to say those two angles are congruent. We got some given information, and we're going to try to prove that angle L is congruent to angle O. Well, in this case, the way we're going to do this is we're going to add the given information to the picture. We'll be able to prove the triangles are congruent and that the whole triangles are congruent. These two angles will be congruent, and that's the CP-CTC rule. So as always with our proofs, the first thing you want to do is take that given information and start marking it in the picture. So here we'd say angle P is congruent to angle N. You go down to the picture and include those marks. And that's the first mark we put in the picture. It also becomes the first statement in our proof. Angle P is congruent to angle N. What's the reason? Well, that was given to us. And we go on to the next piece of information. Segment LP is congruent to segment ON. So we put the tick marks that represent that. Segment LP is congruent to segment ON. And then that becomes our second statement in the proof. LP is congruent to ON. What's the reason? That is also given to us. Next, we're looking at the picture. If that's all our given information, we're going to find what else can we add to this picture. And hopefully you recognize at this point that we can add in these two angles here, these vertical angles, that these two angles have to be congruent. And that's our third statement in the proof. Angle LMP is congruent to angle OMN. What's the reason for that? Those are vertical angles. Now, if we look at this picture, we can see our two triangles are going to be congruent. You should be able to tell which method of congruence it is. We have here our statement that the first triangle and the second triangle are congruent. What's the reason going to be? In this case, this is angle, angle, side. We have two angles and a side, but the side is not the included side, so it can't be angle, side, angle. It's not the side that connects those congruent angles. Finally, now that we know the whole triangles are congruent, we can claim these parts are congruent. Angle L is congruent to angle O. That's step 5 here. And what's our reason for that going to be? That's CP-CTC. That says if the whole triangle is congruent, then the corresponding parts are also congruent. Okay, here's another proof. And in this case, I'm going to ask you to see if you can fill out the reasons before we go through with it. So you're going to take a look at the given information, mark your picture. If you have a sheet of scratch paper, you can mark this. Here are all the statements, and I'm going to ask you to fill in all the reasons. Okay, so the first thing you should have done is taken that given information, put it in the picture. Angle 1 is congruent to angle 3. Mark the picture with those two things. That becomes our first statement, and our reason should be given. Second piece of given information, angle 2 and angle 4 are congruent. We want to mark our picture. That becomes our second statement, and that is also given. Then, what we see in this picture is this segment right in the middle. Segment AG is in both the triangles. It's the bottom of one and the top of the other, but it's congruent. When something is counted in both of them, we say that it's congruent to itself. We'd say segment AG is congruent to segment AG, and the reason is the reflexive property. Now we can see our two triangles are congruent. This is angle, side, angle. The side is the connecting side, the included side. So this is angle, side, angle for number 4, why our two triangles are congruent. And finally, the last question here, why is segment MA congruent to segment ZA? Well, the triangles are congruent, and these are corresponding parts, so that would be CP-CTC.